So today we are going to discuss about a very important chapter, and that is going to be about oogenesis. Okay, so this is a very volatile topic and yet a very interesting topic. It is the beginning of obstetrics and gynecology aspect. So it is very important to learn about this topic in detail. So let's begin with the class. Okay, so what do you mean by oogenesis? So oogenesis is nothing but the process of formation of female gamete. So the process of formation of female gamete is termed as oogenesis. Right, and the female gamete is oocyte, right? So the process of formation of female gamete, which is oocyte, is termed as oogenesis, and this process is going to begin in the intrauterine life. So let's say, for example, a female fetus is going to be in its mother's fetus during the development for about 9 months or 10 months, 9 months. Okay, so during this period of time, when the female fetus is going to be in the mother's womb, the process of oogenesis is going to occur in the female fetus. Okay, so let's discuss about this oogenesis in detail, right? Okay, so this oogenesis begins with the primordial cell. Primordial germ cells. So what are primordial germ cells? So primordial germ cells are nothing but these are the embryonic progenitors. So what are embryonic progenitors? So embryonic progenitors are those cells which will give rise to gametes. So embryonic progenitors are those cells which will give rise to gametes. Let's say, for example, if it is a male fetus, it will give rise to the male gamete, which is the sperm. And if it is a female fetus, it will give rise to the female gamete, which is going to be the oocyte. Right? Excellent. So those is the function of the primordial germ cell. And how this primordial germ cell is going to give rise to this gametes? It is through these primordial germ cells will initially migrate into the gonad of the fetus. Here we are discussing about oogenesis, so let's take about female fetus, right? Okay, so what is the gonad of females? The gonad of female is going to be the ovary, right? Okay, so these primordial germ cells are going to migrate inside the ovary of the female fetus. So once it enters into the gonad of the female, it is going to undergo differentiation. So through this differentiation, these primordial germ cells, as it enters into the gonad of the female, it is going to get differentiated into oogonium. Oogonium, which is 44 plus XX. Okay, now this oogonium is now undergoing mitosis. So as this oogonium undergoes mitosis, all these oogonias are going to get converted into primary oocyte. So as we have discussed that this process of oogenesis is going to occur in the intrauterine life, all these oogonias are going to get converted into primary oocyte. So when a female fetus is going to born, as the female fetus is going to born, her ovary will contain only the primary oocyte, because all these oogonias are going to get converted into primary oocyte by the process of mitosis. So through the process of mitosis, all these oogonias are going to get converted into the primary oocyte, which is also 44 plus XX, right? Okay, now these primary oocyte will enter inside the meiotic division. So first we have discussed about the mitotic division. Now it will enter into the meiotic division. In the entire process of oogenesis, there is going to be one mitosis and two meiotic division. So this is going to be the first meiotic division. So this primary oocyte, which is 44 plus XX, is going to undergo first meiotic division. And this first meiotic division is not going to be completed very soon, because it is going to undergo a stage of arrest. So this first meiotic division is going to get arrested in the diplotin stage of the prophase. So in the diplotin stage of the prophase, this primary oocyte, as it enters inside the first meiotic division, in the first meiotic division, it is going to get arrested in the diplotin stage of the prophase. So when the fetus is going to be born, Okay, so when the female fetus is going to be born, all the primary oocyte will enter the first meiotic division, and in the first meiotic division, it is going to get arrested in the diploiding stage of the prophase. Okay, so when does this first meiotic division is going to get completed? Yes, it is going to be completed only after the female fetus after the female attains puberty. So only when the female attains puberty, after the puberty, just before the ovulation, these first meiotic division, which was arrested in the diploiding stage of the prophase, is going to be completed. So the first meiotic division, which was arrested in the diploiding stage of the prophase, will be completed. Okay, so as we have discussed earlier, the primary oocyte, which is 44 plus XX, which enters the first meiotic division, it will get arrested in the diploiding stage of the prophase. So when the female fetus is born, all these primary oocyte will be in a stage of arrest at the diploiding stage of prophase. So only when the female attains puberty, let's say for example, by the age of 10 to 12 years, when the female attains the puberty, only after the puberty, just before the ovulation that is going to occur in a female on the 14th day of the menstrual cycle, just before the ovulation, this first meiotic division is going to get completed. Okay, so when the first meiotic division is going to get completed, there is going to be formation of secondary oocyte. It is 22 plus X. Now, I know you have the doubt that why it is 22 plus X. We saw that primary oocyte was 44 plus double X, right? Then why secondary oocyte is only 22 plus X? So where is the other 22 plus X? The other 22 plus X is for the first polar body. Now you may ask, what are these polar bodies? See, these polar bodies are nothing but these are the non-functional cells. The non-functional residual cells which are formed during the process of oogenesis. These cells consist of only the nucleus and the cytoplasm, right? Only it contains the nucleus and the cytoplasm, and these are the non-functional cells. We have nothing to do with these cells, but currently these polar bodies are used for pre-implantation genetic testing. So pre-implantation of the zygote for genetic testing, they are using these polar bodies, which are actually the non-functional cells which contains only the nucleus and the cytoplasm, which is 22 plus X. They are using these non-functional residual cells for genetic testing in the pre-implantation period, that is before implanting any blastocyst in the uterine cavity. They are doing this pre-implantation genetic testing with these polar bodies. Okay, so let's have a quick revision now. So what we saw first, that was primordial germ cells, which are the embryonic progenitors. So these embryonic progenitors are going to enter the gonad of the female fetus. What are the gonad? Ovary is the gonad of the female. So as these primordial germ cells are going to enter into the gonad of female, it will get differentiated into oogonium, which is 44 plus X. This oogonium is going to undergo mitosis. Through mitosis, these oogonium are going to be converted into primary oocyte. So at birth, all the oogonias are going to get replaced by the primary oocyte. So no more mitosis occurs after that. So this primary oocyte, now as the child is going to born, as the fetus is going to born, all these primary oocyte will enter the first meiotic division. In the first meiotic division, it is going to get arrested in the diploiding stage of the prophase. So it is going to remain in the stage of arrest. So only after the female attains the puberty, let's say for example around 10 to 12 years of age, just before the ovulation. So just before the day of ovulation, the first meiotic division, which was arrested in the diploiding stage of prophase, is going to be completed. So once it is going to get completed, the meiotic division, once it completes, this primary oocyte is going to be converted into two things. One is the secondary oocyte, which is 22 plus X, and the other is first polar body, which is 22 plus X. So now the secondary oocyte is going to enter into the second meiotic division. So as we have discussed, we have one mitosis and two meiosis in oogenesis. It is going to enter, the secondary oocyte is going to enter into the second meiotic division. Now, the second meiotic division is also not going to get completed very soon. Why? Because is that the second meiotic division will get arrested in a stage called metaphase. So the second meiotic division is going to get arrested in the metaphase. So you may have the doubt that when this metaphase is going to get completed in the female, so this metaphase, which was this secondary oocyte which was arrested in the metaphase, this division will complete only at the time of fertilization. So the division will get complete only at the time of fertilization. What is fertilization? The fusion of the male and the female gamete, the sperm and the oocyte, which results in the formation of the zygote, right? So only at the time of fertilization, only at the time of fertilization, the secondary oocyte which was arrested in the metaphase is going to get completed. So now it is going to release two things. One is the ovum, which is 22 plus X, and other is the second polar body. So we all know at the time of fertilization what is going to happen. The male gamete, which is going to be the sperm, is going to fuse with the ovum and it is going to form into the zygote, right? So only at the time of fertilization, when the male gamete is going to come, the secondary oocyte which was arrested in the metaphase is going to get completed and this ovum is going to get released. And once the ovum is going to get released, the process of fertilization is going to get completed. And the second polar body is also 22 plus X, which is also a non-functional residual cell which is formed during the process of oogenesis. So ovum is also 22 plus X and the second polar body is also 22.X. Yes, very good. So all these things which we have discussed is all about oogenesis, right? So from the primordial germ cells, it gets migrated into the gonad of the female, that is the ovary. Differentiation is going to happen. So oogonia is going to form, which is 44 plus XX. Then mitosis occurs. No more mitosis occurs after that. So primary oocyte is formed. So all the oogonias are going to get converted into the primary oocyte. So when the female is going to born, when the female fetus is born, it has all the primary oocyte which is going to get arrested in the diploiding stage of the prophase of first meiotic division. So just before the ovulation, when the female has attained the puberty, the first meiotic division which was arrested in the diploiding stage of prophase is going to get completed. Now, since it's getting completed, the primary oocyte will get converted into the secondary oocyte and the first polar body. The secondary oocyte, which is 22 plus X, will now undergo second meiotic division. In the second meiotic division, the secondary oocyte is going to get arrested in the metaphase. So when does this arrest is going to be completed? It will get completed only at the time of fertilization. So at the time of fertilization, the ovum and the second polar body is going to get released and this ovum is going to fuse with the male gamete, which is the sperm, and it's going to result in the formation of the zygote, right? Excellent. So this is all about oogenesis. Okay, so as we have discussed, this formation of oocyte is going to begin in the intrauterine life itself. So what are the amount of follicles which can be expected in a female? Right? So let's say, for example, 5th month of intrauterine life. How many follicles you can expect in a female? The maximum number of follicles which are going to be present in a female is around 5th month of intrauterine life, because in the 5th month of intrauterine life itself, we know that oogenesis is going to happen. So the oocyte is going to be maximum in amount in the 5th month of the intrauterine life. So it is going to be around 6 to 7 million. Okay, and then at birth, as we know, all these oogonium was going to get converted into the primary oocyte. It is going to become around 1 to 2 million. After that, at around puberty, as we know, at around puberty, all these primary oocyte will get converted into secondary oocyte and the first polar body. It is going to become 4 lakhs to 5 lakhs. So as we are seeing that there are only a definite amount of follicles which are present, and these are getting depleted throughout the cycle of a female. So at 5th month it is going to be 6 to 7 million, at birth it is going to be 1 to 2 million, at puberty it is going to be 4 lakhs to 5 lakhs. So throughout the life of a female, the number of follicles is actually going to get depleted. So at around menopause, what is menopause? Menopause is cessation of menstruation. So at around menopause, let's say for example around 47 to 50 years, 51 years, there is going to be decreased amount of ovarian reserve. So the ovarian reserve is going to be depleted at around the menopause, since there are only definite amount of follicles being present in a female. Excellent. Now it is also important for us to know at around how many weeks of intrauterine life these are going to form, right? So the oogonia is going to be formed at around 9 weeks. At around 9 weeks, the oogonium is going to form. The primary oocyte is going to be formed at around 12 weeks. Right? And the follicle formation will begin at around 14 weeks. The follicle formation will begin at around 14 weeks and it gets completed in around 24 weeks. So the follicle formation begins at around 14 weeks and gets completed at around 24 weeks. So these are the timeline when these cells are going to get formed. So oogonia get formed by 9 weeks, primary oocyte by 12 weeks. So when this primary oocyte is going to enter the first meiotic division and arrested in the diploiting stage of the prophase, the follicle formation is going to begin, right? Yes. So what are these follicles? These follicles are nothing but the oocyte, which is going to be surrounded by cuboidal granulosa cells. So the oocyte, so let's say for example this is the oocyte, and this oocyte is going to be surrounded by the cuboidal granulosa cells. So the oocyte, which is going to be immature, surrounded by the granulosa cells, these will form the follicles. So the follicle formation begins at around 14 weeks and completed by around 24 weeks. So this is all about the oogenesis. Now we have some extra points here. So let's learn as well here. Okay. Yes. So we have seen that there is going to be one mitosis and two meiosis. One mitosis, two meiosis, and 2 polar bodies. So we have nothing to do with the polar bodies. Both polar bodies are 22 plus X, 22 plus X, right? Okay. Now, mitosis and meiosis. So there is going to be one mitosis where all the oogonium are going to convert it into the primary oocyte. Right. Okay. What is this first meiosis and second meiosis? These primary oocyte will enter into the first meiotic division and get arrested in the diploiting stage of the prophase. So that is first meiosis. What is the second meiosis? That is after the completion of the first meiotic division, there is going to be formation of secondary oocyte and the first polar body. This secondary oocyte now will enter into the second meiosis, which will get arrested in the metaphase, which will get resumed or get completed at the time of fertilization. It is about first and second meiosis, right? Okay. So what is the size of a mature ovum? The size of a mature ovum is going to be around 120 to 130. So it is going to be around 120 to 130. So this was a previous year question as well. So the size of a mature ovum is going to be 120 to 130. Right? And what is the fertilizable lifespan of the ova? So once the ova is going to be released, what is the fertilizable lifespan? So the fertilizable lifespan of the ova is around 12 to 24 hours.